Uranus, the ice giant. This planet will blow your mind. Let's reveal the facts about Uranus and smash that subscribe button. First, Uranus sits nearly 3 billion kilometers from the Sun, twice as far as Saturn. Light from the Sun takes over 2.5 hours to reach it, making Uranus a true outpost in the solar system. It's the first of the ice giants, with a composition distinct from Jupiter and Saturn: less hydrogen and helium, more ices like water, ammonia, and methane. For centuries, Uranus was invisible to the naked eye, mistaken for a faint star until telescopes revealed its true nature. Its distance shapes everything: its cold, its faint sunlight, and its unique chemistry. Uranus isn't just another planet, it's a whole new class, existing in a realm of darkness and cold. Let's see how it was finally discovered. Second, until 1781, Saturn marked the edge of the known solar system. That changed when William Herschel, scanning the sky with his homemade telescope, spotted a fuzzy object moving among the stars. At first, he thought it was a comet, but its nearly circular orbit revealed it was a new planet, far beyond Saturn. This discovery shattered ancient boundaries and expanded our cosmic map for the first time in history. Herschel wanted to name it George's Star, but astronomers settled on Uranus, after the mythological father of Saturn. Uranus was the first planet found with technology, not the naked eye, a triumph of the scientific revolution. Its discovery inspired astronomers to search for more worlds in the darkness beyond. Uranus's orbit would even lead to the discovery of Neptune, as astronomers noticed something tugging at its path. The age of exploring the outer solar system had begun. Now, let's look at what makes Uranus so different from its giant neighbors. Third, unlike Jupiter and Saturn, Uranus is an ice giant. Its atmosphere is mostly hydrogen and helium, but beneath that lies a massive mantle of hot, dense ices, water, ammonia, and methane, surrounding a rocky core. These ices aren't frozen like ice cubes. Under immense pressure, they form a strange, slushy, electrically conductive fluid. Uranus likely formed in a colder, less dense region of the solar nebula, capturing less hydrogen and helium than Jupiter and Saturn. This unique composition sets Uranus and Neptune apart, hinting at a different origin story. Uranus is about 14.5 times the mass of Earth, but it's a very different kind of giant. Now let's talk about its most bizarre feature: its tilt. Fourth, Uranus's most striking feature: its axis is tilted nearly 98 degrees, so it spins on its side. For 21 years at a time, one pole basks in constant sunlight while the other is plunged into darkness. This creates the most extreme seasons in the solar system: decades of day, then decades of night. During equinoxes, Uranus experiences a rapid day-night cycle, but for most of its orbit, the poles dominate. Strangely, temperatures remain fairly uniform across the planet, suggesting complex atmospheric circulation. How did Uranus get knocked over? The leading theory: a massive collision with a protoplanet in its early history. This impact could also explain the odd orbits of its moons and rings. Uranus's sideways spin is a cosmic accident that shaped everything about the planet. Let's explore those mysterious rings next. 10. Fifth, Saturn rings are iconic, broad, bright, and easily visible even through small telescopes. But did you know Uranus has rings too? In fact, Uranus boasts 13 distinct rings, though they're so faint and narrow that most people have never seen them, even in powerful telescopes. The discovery of Uranus's rings was a complete accident. In 1977, astronomers were observing Uranus as it passed in front of a distant star. Suddenly, the star's light blinked out several times before and after Uranus itself crossed in front. This stellar occultation revealed the presence of multiple thin rings, making Uranus only the second planet known to have a ring system at the time. The rings are incredibly dark, so much so that they reflect less light than charcoal or even coal. Unlike Saturn's icy, glittering rings, Uranus's rings are made of radiation-processed organic material, possibly mixed with rock and a little ice. This makes them nearly invisible, except when backlit by a star or the sun. Scientists believe the ring's darkness comes from billions of years of exposure to cosmic radiation, which breaks down ices and leaves behind a residue of complex, carbon-rich molecules. This is why Uranus's rings are some of the darkest objects in the solar system. The ring particles themselves range in size from tiny dust grains to massive boulders several meters across. Unlike Saturn's rings, which have a lot of fine, powdery material, Uranus's rings are mostly made up of larger chunks, with very little dust in between. When Voyager 2 flew by Uranus in 1986, it captured the first close-up images of the rings. The spacecraft revealed that the rings are kept narrow and sharply defined by the gravitational influence of tiny shepherd moons that orbit just inside or outside the rings, hurting the particles and preventing them from spreading out. These shepherd moons, like Cordelia and Ophelia, play a crucial role in maintaining the structure of the rings. Without them, the rings would quickly disperse and fade away. Uranus's rings are organized into two main groups: an inner set of 9 narrow, dark rings, and an outer set of 2 broad, faint rings. The outermost ring, called the Epsilon ring, is especially interesting. It shows subtle hints of blue and red, possibly due to differences in particle size or composition. Over the years, astronomers have used the Hubble Space Telescope and ground-based observatories to study the rings in more detail. They've discovered that the rings can change over time, possibly due to collisions or shifting gravitational influences from Uranus's many moons. Some of the rings are so faint they're only visible in infrared light, and new, even fainter rings have been discovered in recent years. Scientists think there may be more rings yet to be found, hidden in the planet's shadowy outskirts. These subtle, mysterious rings add another layer of intrigue to Uranus's story, hinting at a violent past and ongoing changes in the planet's dynamic environment. But as fascinating as the rings are, Uranus's moons are even stranger. Sixth Uranus has at least 27 moons, named after Shakespearean and Pope characters. The 5 largest, Miranda, Ariel, Umbriel, Titania, and Oberon, are worlds of rock and ice. Titania is the biggest, but Miranda steals the show. Its surface is a chaotic patchwork of canyons, cliffs, and jumbled terrain. Verona Rupes, a cliff on Miranda, may be up to 10 kilometers high. Jumping off would take you over 10 minutes to fall. Miranda's bizarre surface suggests it was shattered and reassembled by ancient impacts. The inner moons help shape the rings, while the outer moons are likely captured objects. Each moon tells a story of violence, ice, and cosmic history. Now, what gives Uranus its signature blue-green color? 7th, Uranus' pale blue-green color comes from methane in its upper atmosphere. Sunlight hits the planet, and methane absorbs red light, reflecting blue and green back into space. This is similar to why Earth's sky is blue, but on Uranus, methane is the key. The planet's atmosphere is mostly hydrogen and helium, but just 2% methane makes all the difference. Beneath the calm blue, temperatures plunge to 224 degrees, the coldest in the solar system. There's no solid surface. The gas thickens into a hot, dense, icy mantle as you go deeper. Uranus's color is just the surface of a truly alien world, but its orbit and seasons are even stranger. 8th Uranus takes 84 Earth years to orbit the Sun, almost a human lifetime. Since its discovery, it's only completed about 2.5 orbits. Each pole gets 21 years of sunlight, then 21 years of darkness, with long equinoxes in between. A day on Uranus is just 17 hours, but its atmosphere and interior rotate at different speeds, with winds up to 900 km/h. Imagine living at the pole. Decades of day, then decades of night, with the sun circling the sky every 17 hours. Uranus's rhythm of time is unlike anything on Earth. Its long year and short day create a world of extremes. But why is it so cold? 9th, despite being closer to the Sun than Neptune, Uranus is the coldest planet. Its atmosphere drops to 224 degrees, just 49 degrees above absolute zero. Unlike other giants, Uranus radiates almost no internal heat. Its heat engine seems stalled. Theories suggest a giant impact may have expelled its heat, or that a barrier traps warmth deep inside. This lack of internal heat makes Uranus's atmosphere calm and featureless compared to stormy Neptune. Deep inside, pressures may be so high that methane breaks down, forming diamond rain that sinks toward the core. Uranus is a world of frigid mysteries, quiet on the outside, wild within. Its discovery changed everything. 10th Uranus discovery shattered the ancient boundary of the solar system and proved there was more to find. It was the first planet discovered with a telescope, opening the door to modern astronomy. Tracking Uranus's orbit led directly to the discovery of Neptune, as astronomers noticed its path was being tugged by something unseen. Uranus doubled the size of the known solar system and inspired generations to look further. It stands as a monument to curiosity, technology, and the human drive to explore. Uranus is more than a distant blue dot, it's the key to a much larger universe. Let's quickly recap Uranus, a planet of extremes, from its sideways spin to its diamond rain and chaotic moons. Every fact about Uranus pushes the boundaries of what we know about planets. I hope you've gained a new appreciation for this overlooked ice giant. What surprised you most? The 21-year seasons Miranda's cliffs or the record-breaking cold? What are your thoughts about Uranus?